You can mail us at info@matlabassignmentexperts.com, info@matlabassignmentexperts.com, or reach us at https://www.matlabassignmentexperts.com. Problems. For each of the following sequences, determine the associated z-transform, include ing the ROC. Make use of properties of the z-transform wherever possible. A x1 n equals I u n b x2 n equals -3 u n c x3 n equals 11 n plus x2 n d x4 n equals xl n minus 5 e x5 n equals 11 n plus 51 f x6 n equals I u n g x7 n equals 11 n asterisk x6 n. A causal LTI system is described by the difference equation y n dash 3y n minus 1 plus 2y n minus 2 equals x e n. A. Find h z equals y z slash x z. Plot the poles and zeros and indicate the ROC. B. Find the unit sample response. Is the system stable? Justify your answer. C. Find y n if x n equals 3 inch u n. D. Determine the system function, associated ROC, and impulse response for all LTI systems that satisfy the preceding difference equation but are not causal. In each case, specify whether the corresponding system is stable. 1. 2. MATLABassignmentexperts.com. Carry out the proof for the following properties from Table 10, 1 of the text, page 654. A. 10.5.2, B. 10.5.3, C. 10.5.6. Hint: consider. Consider the second-order system with the pole zero plot given in Figure P23.4. The poles are located at z equals re, z equals re dash, and h, 1 equals 1. 3. 4. MATLABassignmentexperts.com. A. Sketch H E. I as 0 is kept constant at w/4 and with r equals 0.5, 0.75, and 0.9. B. Sketch H EIN as r is kept constant at r equals 0.75 and with 0 equals r/4, 27 r/4, and 37 r/4. Consider the system function. A. Sketch the pole zero locations. B. Sketch the ROC assuming the system is causal. Is the system stable? C. Sketch the ROC assuming the system is stable. Is the system causal? D. Sketch the remaining possible ROC. Is the corresponding system either stable or causal? Consider the continuous time LTI system described by the following equation. A. Determine the system function Hs and the impulse response He, T. B. Determine the system function HD, Z, of a discrete time LTI system obtained from Hs through impulse invariance. C. For t equals 0.01, determine the impulse response associated with HD, Z, HD, N. D. Verify that HD, N equals HC, NTIV for all N. 5. 6. MATLABassignmentexperts.com. Consider a continuous time LTI filter described by the following differential equation. A discrete time filter is obtained by replacing the derivative by a first forward difference to obtain the difference equation. Assume that the resulting system is causal. A. Determine and sketch the magnitude of the frequency response of the continuous time filter. B. Determine and sketch the magnitude of the frequency response of the discrete time filter for t equals 2. C. Determine the range of values of t, if any, for which the discrete time filter is unstable. 7. 8. Consider an even sequence x, n, i.e., x, n equals x, n, with rational z-transform x, z. A. From the definition of the z-transform show that. B. From your resultant part, A. Show that if a pole, or a zero, of x, z, occurs at z equals zo, then a pole, or a zero, must also occur at z equals 1/zo. MATLABassignmentexperts.com. C. Verify the result in part B for each of the following sequences: I, B, n plus 1, plus B, n minus 11, 2, 6, n plus 1, dash, rkn, plus B, n minus 1. D. Consider a real-valued sequence y, n, with rational z-transform y, z. I. Show that y, z, equals y asterisk, z asterisk. 2. From part I. Show that if a pole, or a zero, of y, z, occurs at z equals zo, then a pole, or a zero, must also occur at z equals z star. E. By combining your result in part B with that in part D, show that for a real, even sequence, if there is a pole, or a zero, of h, z, at z equals pj, then there is also a pole, or a zero, of h, z, at z equals pej, at z equals 1/pe, and at z equals 1/pe dash. In section 10.5.5 of the text, we stated the convolution property for the z-transform. To prove this property, we begin with the convolution sum expressed as A. By taking the z-transform of EQ, P23.9-1, and using EQ, 10.3, of the text, page 630, show that 9. Where x2, z, equals z, x2, nk. MATLABassignmentexperts.com. B. Using the result in part A and the time-shifting property of z-transforms, show that. C. From part B, show that. Consider a signal x, n, that is absolutely summable and its associated z-transform x, z. Show that the z-transform of y, n, equals x, n, u, n, can have poles only at the poles of x, z, that are inside the unit circle. Let hc, t, sc, t, and h's denote the impulse response, step response, and system function, respectively, of a continuous time, linear, time-invariant filter. Let HD, N, SD, N, and HD, Z denote the unit sample response, step response, and system function, respectively, of a discrete time, linear, time-invariant filter. Consider a continuous time filter with input xc, t, and output yc, t, that is described by a linear constant coefficient differential equation of the form 10, 11, 12. MATLABassignmentexperts.com. The filter is to be mapped to a discrete time filter with input x, n, and output y, n, by replacing derivatives with central differences. Specifically, let v, k, x, n denote the kth central difference of x, n, defined as follows. The difference equation for the digital filter obtained from the differential equation, P23.12-1, is then A. If the transfer function of the continuous time filter is HCS and if the transfer function of the corresponding discrete time filter